right, today we're going to talk about the difference quotient. And what the difference quotient is used for in future classes that you'll see is that you are going to use it to find the slope of things that are not straight lines. Okay, sometimes if we have a function that's a linear function, so for instance, it's some kind of straight line like that, there's several different ways we can find the slope of that. If we are given the equation of the line, like if it tells us y equals 3x plus 1, we would know that this is in what's called y equals mx plus b in slope-intercept formula, and 3 would be the slope of that line. Okay, there's other ways that we can find slope of straight lines also, but let's say your graph is not a straight line. Say it's something like this. And you want to find what the average slope of that is. That's what this formula is going to help you find. Okay, so we're just going to learn how to use it in this class, how to plug in and find and use the difference quotient. Okay, the difference quotient is f of x plus h minus f of x over h. So it's going to give us a function and then say apply the difference quotient to your function. Like in number 1 says f of x equals 3x minus 7. And it says to use the difference quotient on this. So what I'm going to do is the first part of the difference quotient says find f of x plus h. That means go to your function, which is 3x minus 7, and replace the x with x plus h. So let's look what that looks like. Just rewriting this, replacing the x with x plus h. So I have 3x plus h minus 7. So there's that part. I've replaced the x with x plus h. The second part of the numerator says to subtract the function. So I'm going to subtract this whole thing right here, all of 3x minus 7. And I am putting it in parentheses for a reason. If I'm subtracting the whole function and I don't put parentheses around it, if it just looked like this, then I would just be subtracting the 3x. I don't want to just subtract the 3x. I want to subtract the whole function. Now, the denominator is going to be h. We're just going to put it in at the end when we need to use it. So first of all, let's clean up this right here by distributing the 3 here and distributing that negative here. So let's see, I have 3 times x, which gives me 3x, plus 3 times h, which is 3h. Bring down my minus 7. Distribute this negative to remove those parentheses. So I'm going to have minus 3x, and then this negative turns that negative into a positive 7. So once you do that, there's going to be some cleaning up to do. When you distributed this negative here, it turned those signs to opposites of what they started off being, which means they're actually going to end up canceling something up front to help us simplify this. So everything that was in the second part should cancel something up front. So since there's a positive 7 here, there should be a negative 7 up here. And there is, so they cancel. This negative 3x will cancel out that positive 3x. So what's the only thing you're left with after you clean it up by canceling? The only thing you're left with is that 3h. Now we're going to put the denominator in. Remember, my denominator is h. So now that I have h over h, they cancel, and my answer is 3. So I could have looked at this function at the beginning and told you what my answer was going to be because it is linear. It's just x. It's not x squared or x cubed or anything like that. It's just x, which means the beginning of this was in y equals mx plus b, which means the number in front of x, which is this 3, ended up being my slope. That if I graphed 3x minus 7, it would be a straight line, which means the slope of it is what the answer was going to end up being. Now, there is a method to this madness because once we get to x squared and x cubes, we're going to need this practice of distributing and canceling to clean things up. Okay, so there is a reason we are doing it, even though I can look at that function and tell you this answer is going to be 3. Same on number 2. Let's look at number 2. F of x equals negative 5x plus 6. Once again, since that's just an x, not an x squared or an x cubed or an absolute value of x or anything like that, it is linear, which yes, that does mean that my answer should end up being negative 5. Negative 5 is the slope of that line, but we want the practice for when we have to get to the next problems and they are more tedious. Okay, so let's go ahead and practice replacing the x with x plus 8. So I'll have negative 5, replace the x with x plus 8, plus 6. So there's the front part of the formula. Now I want to subtract, and remember, when you subtract, you want to put that second part in parentheses. What am I subtracting? I'm subtracting f of x. Well, f of x is negative 5x plus 6. So that's what I'm subtracting. So once you plug in the f of x plus h and then subtract the f of x from it, the next step is always going to be to distribute, to remove those parentheses and clean things up. So let's see, if I distribute this negative 5 here and that negative there, let's see what it's going to leave me with. Negative 5 times x is negative 5x. Negative 5 times h is negative 5h. Bring down my plus 6. Now here, remember, I'm always distributing a negative there, which is going to turn those signs opposite. Turning those signs opposite in that second part of the difference quotient is what helps us cancel stuff up front. Because what is distributing this negative turn that negative 5x into? A positive 5x. Distributing this negative turns that positive 6 into a negative 6. Again, that's going to help us clean things up. So let's see what cancels. This negative 6 cancels the positive 6. The positive 5x cancels the negative 5x. So let's see what is left. The only thing left is negative 5h. And remember what your denominator from the difference quotient always is. It's always 8, which means that 8 will cancel that one. And like we knew from the beginning, I did end up as negative 5 for my answer. Now, let's look at number 3. This is when things get more interesting. F of x equals x squared plus 7. All right, this is one where I can't tell by looking because it's not linear, it's quadratic, right? It's got x squared instead of x, which makes it where, this is why we did the practice, because now it's going to get more difficult replacing the x with x plus 8, which is the first thing I got to do for the difference quotient. Let's find f of x plus h, which means go to your function and replace this x with x plus h. So let's see what that gives me. Right off the bat, I have an x. So that's where I'm going to put my x plus h. I got to square it and drop down my plus 7. So there's f of x. Now what do? Now I subtract f of x. So minus, and remember, put in parentheses the whole function, x squared plus 7. Now, over here, the first thing I got to do now is remove those parentheses by squaring what's inside of there. And what does squaring x plus h mean you need to do? It means you need to multiply x plus h times x plus h, right? You're squaring it, which means you're multiplying it times itself. So I'm going to do that over here. And then just keep it handy. Just go ahead and highlight it or circle what you get when you answer, so you don't have to do this step every single time you see x plus h squared. You're just going to be able to plug something in there now. So again, x plus h squared over here. So let's FOIL. My first, x times x, gives me x squared. My outer, x times h, gives me plus xh. My inner, h times x, gives me another xh. And then my last, h times h, gives me h squared. Now, look at these middle two terms. They are both xh's, which means I can put those together, right? There's no reason to write those as two separate terms. They are like terms. They are both xh's. There's one of them here and one of them here. So you actually have two xh's. So I have x squared. Put those together to get 2xh plus h squared. So this is what I'm talking about to keep handy. Every time you see x plus h squared, don't mess with going through and doing all this work all the time. Put a star next to this and say, every time I have x plus h squared, I'm going to plug this in. So x plus h squared gives me x squared plus 2xh plus h squared. Now bring down my plus 7, and then remember, distributing this negative is what's going to help us clean things up by combining like terms. So let's see, if I distribute my negative, that turns out to negative x squared. It turns out positive 7 into negative 7. So remember, everything you distributed a negative to, now those terms are going to clean up by canceling something up front. So let's see, this negative 7 cancels out the positive 7. This negative x squared cancels out positive x squared. So now let's look at what we have left. I've got 2xh plus h squared left. Now remember what the denominator of your difference quotient is. It is h. Now, I can simplify this. That means to divide everything in the numerator by h. There's a couple of ways you can go about doing that. If you're dividing it by h, each term in this numerator is just going to lose an h. You're dividing an h out of that, which means, let's see, if this one loses an h, what's going to be left? 2x plus, if I pull an h out of h squared, what is left? An h would be left, right? So this right here, if I had h squared, but I pulled one of the h's out, I still have an h left. So that is your answer, 2x plus h. So what I'm going to do is write x plus h squared up here. And every time I see that, I'm going to replace it with x squared plus 2xh plus h squared. Okay, let's look at number 4. Number 4 has f of x equals 10x squared plus 2x plus 4. All right, this one has a little more work. So I started off by finding f of x plus h, which means go to your function. Wherever you see x, you're going to replace it with x plus h. So I see it in 2 spots. So I'm going to rewrite this, replacing both of these x's with x plus h's. So let's see what that gives me. I've got 10. Instead of x, I write x plus h squared plus 2 times x plus h. Drop down my plus 4. So again, all I have done is rewritten my function, and I replaced both of those x's with x plus h's. What's the second part of the numerator? You subtract what? The whole function. So this whole thing, I'm going to put my in parentheses behind that minus. So 10x squared plus 2x plus 4. So remember when we did this x plus h squared on the last problem, and then I wrote it up there. That's why you want to keep it handy. You don't want to have to FOIL x plus h every time you see it. You've done it once. There's no need to do it again. What do I put when I have x plus h squared? Bring down that 10. Remember, here's what I ended up with when I FOILed it. X squared plus 2xh plus h squared. So that's what I put in its spot. X squared plus 2xh plus h squared. Now I'm going to distribute the 10 to get rid of those parentheses. I'm going to distribute that 10. I'm also going to distribute this 2. And then I'm also going to distribute that minus to everything in that last parentheses. So that's going to get rid of all my parentheses in the whole problem. So I'll be able to clean it up. So let's distribute the 10 to see what we get. We get 10x squared plus 10 times 2 gives me 20xh plus 10 times h squared gives me 10h squared. So that removes those parentheses by distributing the 10. Now I'm going to distribute this 2 to this parenthesis so I can remove it. So 2 times x gives me plus 2x plus 2 times h gives me 2h. Bring down my plus 4. The last part is I'm going to distribute that negative to all 3 of those terms to see what that does. So I'm going to have minus 10x squared minus 2x and minus 4. Now remember, distributing that minus to all of those actually helps me clean things up, right? Everything that you just distributed, that -2, is all going to cancel a term up here. So let's see, this -4 should have a +4 to cancel. And there it is. This -2x should have a +2x to cancel. And there's that. And this -10x squared will have a +10x squared to cancel. And there's that. So I'm going to write what I have left. I've still got a 20xh. I've still got a 10xh squared. So 20xh, 10x squared, and +2h. And remember, what is your denominator of your difference quotient? Always. It's always an h. So if you will notice, when you did all this canceling of those terms, what did they cancel? They canceled every single term that did not have an h, right? This -4 canceled that +4. It didn't have an h. This -2x canceled that +2x. This -10x squared canceled that +10x squared. So when you were all said and done with your canceling, everything that was left were just the terms that had the h's. That is because, look at your denominator. Your denominator is an h, which means I want to divide the whole numerator by h. That's what the fraction bar means. It means divide everything in the top by h. So let's see what that gives me. If you're dividing by h, every term you are dividing h by h is going to lose an h. So let's see. If this first term loses an h, it'll just be left with 20x plus. If this second term loses an h, well, if it had an h squared, but it lost an h, I'm just going to be left with 10h plus. This last term, if I pulled its h out, I'm just going to be left with 2, and that's your answer. All right, last one. This one, the last one, the function is f of x equals 3x cubed. Makes it even more interesting now, because now not only is my x not just an x or an x squared, now it's an x cubed. So let's see what I'm going to do here. I need to find f of x plus h, which means go to your function and replace its x with x plus h. So if I do that, I will have 3 times, instead of x, I'll have x plus h to the third power. What do you do after f of x plus h? You subtract the function, so minus, what is my f of x? What is my function? It is 3x to the third. So let's see, I need to find what x plus h to the third power is. Now, I'm going to do this over here, and this is also something that I would keep handy so I don't ever have to do it again. I already don't need to find x plus h squared because I've got it written out. Let's see what x plus h to the third is. We've already done most of the legwork here. right? Because there's what x plus h to the third power means. But remember, we've already done x plus h times x plus h, right? That's what we got when we did x plus h squared. What did this end up being? It ended up being this. So that's the first part. X plus h times x plus h gave me x squared plus 2xh plus h squared. So if I'm going to cube it, I just need to multiply what this is times x plus h. So there's what I'm going to do now. Once I get my answer, I'm going to save it so I don't ever have to do it again. So I'm going to do a lot of distributing here. The first thing I have is x squared times x, because what you're doing is you're distributing each one of these terms in the first parenthesis to both of those terms in the second. So I'm going to have x squared times x, which gives me x to the third. X squared times h just gives me x squared h. So I'm done distributing x squared. Now I've got to distribute this 2xh to both of those. So let's see what I get there. I have 2xh times x. What's going to turn into being squared? What do both of these terms have? They both have an x. So when I multiply these x's together, my x is going to turn to x squared. So I've got 2x squared h. Now, I've got to do the 2xh times the h. Now who's turning squared? I've got h in this one and h in this one. So my h is what's going to turn squared. So I've got 2xh squared. So I'm done with this one. Now, what's the last thing I have to distribute? I've got to distribute this h squared to both of those. So see why you don't want to have to do this again? I have h squared times x, which just gives me h squared x. Again, h squared times x just gives me h squared x. Then my last part, h squared times another h gives me h to the third. So let's clean this up and then never have to do it again. So I'm putting together like terms. There's no other x cubes. Let's see. Here's an x squared h, and this term has x squared h. These are like terms that I can put together. These do not look like this, right? What is squared in both of these terms? The x is squared, but the h is not. That's why they're like terms. Here, the h is squared, not the x. So that's why I don't put these with these. So let's see, how many x squared h's do I have? I've got 1 here and 2 here. So together, I've got 3 x squared h's. Now, I can put these two terms together because they are also like terms. Now, I did this on purpose just to remind us what a like term is. The x and h's don't have to be in the same order. They just have to have the same exponent. So here I have a plain x with an h squared. Here my h is squared, just like this term, in a plain x. So even though the xh is flip-flopped, the x is still just an x and the h is squared. So again, those are like terms also. So when I put those together, I have 3 of them again. And you can write it either way, either x, h squared, or h squared x. Either way, I'll write it h squared x. And then drop down your plus h to the third power. So, anytime you have x plus h to the third power, so you don't have to do all that again, save this. X plus h to the third is x to the third plus 3x squared h plus 3h squared x plus h to the third. So that way, here's what you want to say when you're doing this homework. It saves you from having to do all of that ever again. So if you have an x plus h squared, you plug in this. If you have x plus h to the third, you plug in all of that, which is what we have here. Right? So I have 3. Then I have x plus h to the third power. What did I figure all that was? It is this. It is x to the third plus 3x squared h plus 3h squared x plus h to the third. Close your parentheses. So there's x plus h cubed, all that mess. Minus, just drop down that 3x cubed. Let's distribute our 3. And then clean it up. So if I distribute this 3 times x cubed is 3x cubed. Plus 3 times 3 gives me 9x squared h. Three times 3 again gives me plus 9h squared x. Plus 3 times h to the third is 3h to the third. And drop down your minus 3x to the third. Now, the only thing that I had to distribute that minus to was that 3x cubed. So that's the only thing that's going to clean up here. Is this negative 3x cubed will cancel out the positive one. Now, remember, what is your denominator of the difference quotient? All of this is over h, right? The whole thing is over h. And if you'll look what all 3 of those terms have in them. They all have an h in them. So you're going to divide out that h from all of them. So let's see what that'll give me. They're all just going to lose an h. So let's see, if I divide this first term by h, this h will cancel that one. So I have 9x squared. Here, if I divide this term by h, since it had an h squared and I'm only taking out one of the h's, it's still going to have an h. It's just not going to be squared anymore. So I'm going to have 9hx plus, I'm dividing this last term by h. Well, since it started off with h to the third, and I'm only pulling out one of the h's, I'm going to be left with 3h to the second, right? I only pulled out one h, so that leaves me with plus 3h to the second, which is your answer. Okay? Now, this is the last section that is covered in our second test. The test is not due this Sunday, it's due next Sunday. We're going to, on Monday, do the test number 2 review. And then your test and the test review will be due next Sunday. What I also want to talk about is registration for continuing students, which you all are, starts next Tuesday. So classes will be available for you to register for spring and summer, I think, summer maybe, but definitely spring, for you to go ahead and register. Even if you do not know, you need to contact your advisor, or I can help you if you need to email me. And we can look at your degree plan to see what you need to register for. Classes are gonna fill up. They're gonna be offered the same way they were this semester in that high flex model, because I'm assuming that COVID will still be an issue on campus. So you can either sign up, there will be plenty of online options. Then there will be the options like we had this semester, to where you sign up for the Monday, Wednesday, Friday high flex model, and then your instructor will have you choose a day. Or you can do virtual, even if you do on-campus choices. You can always opt to do those on-campus classes virtual, like a lot of you are doing this semester. But there is no reason to not go ahead and register for classes, even if you have a potential of your schedule changing later on down the road. Go ahead and register, and then if you need to rearrange your schedule later on, rearrange it. It's not that hard to do. I can help you with that if that's something that needs to happen later on. And I say this because I think a lot of the classes are going to fill up, especially sciences. If you need to take biology, microbiology, AMP1 or AMP2, those classes fill up extremely fast. They will fill up, especially at the good times. If you want, like the 9 or 10 o'clock or the 9:25 or 10:50 on Tuesday, Thursday, those classes are going to fill up extremely fast. So go ahead and get your spot in one of those classes. And then later on, if you decide you need to go to night school or whatever, then just change it. Okay. All right. So that is it for today. I will put the YouTube up here right now. Since we finished early, I'll have time to do it right now. And have a good weekend, and I will see y'all next week.